The purpose of this presentation is to explore empirical evidence related to resistance training for endurance athletes. In the past, endurance athletes typically only performed endurance activities related to their particular sport. This discussion will explore the effects of adding resistance training to an endurance athlete's training regimen. We will also compare and contrast VO2 max, lactate threshold, and running economy in groups utilizing either endurance training only or resistance training in addition to endurance training. Beginning with VO2 max, which can be described as relative VO2 max, which is related to body weight, or absolute VO2 max, which is not. Endurance athletes seek to improve VO2 max in hopes of improving race performance, which is the ultimate gauge of the big picture. And although VO2 max is not the perfect predictor of race performance, top endurance athletes generally have a high VO2 max. Next, we will consider lactate threshold. Lactate threshold represents the point at which lactate accumulation exceeds lactate removal. The higher the lactate threshold of the athlete, the faster that athlete will be able to run continually. In other words, they will run at a higher percentage of their VO2 max. Also, we will observe changes in running economy. Running economy is the relative amount of oxygen consumed for a given speed. A runner consuming less oxygen per speed is said to have a higher economy. Looking at the literature available, the first thing that must be considered is whether or not the subjects had been training prior to the study. If an individual has not previously trained or is overly sedentary, they are likely to improve in all aspects related to fitness. Conversely, if a test subject has trained for their endurance sport and are given a new training regimen, that subject's body will elicit training responses, but whether or not those responses translate into better performance in their chosen discipline has yet to be solidly determined. This is the purpose of this review. In the study listed at the top of the chart, a group of trained female cross-country runners weight trained 3 days per week. The resistance training program involved 2 to 3 sets of 6 to 20 repetitions, depending on the exercise, for 14 different exercises for 10 weeks. Following the resistance training program, the athlete showed a 4% improvement in running economy. Pavolainen et al., listed first under the explosive resistance training heading, found an 8.1% improvement in running economy in trained distance runners in 9 weeks by having them perform explosive movements including leg press, leg curls, and leg extensions in addition to plyometrics. The athletes in this study improved 5K running time by 3.1% without a change in VO2 max. The greatest improvement in running economy was observed by Hoff et al. In trained female cross-country skiers. They performed 3 sets of 6 repetitions, 3 days per week for 9 weeks. The exercise was one that mimicked the double poling motion used in cross-country skiing. Their work economy, which is described as oxygen consumption related to double poling speed rather than running speed, improved by 22%. Time to exhaustion, strength, and peak force also improved. The evidence presented here shows that resistance training can improve performance in a lab in endurance athletes by improving running economy. More studies are needed in order to understand why economy is improved and could include the following speculative reasons: improvements in the stretch shortening cycle, regulation of muscle stiffness, mechanical efficiency, increased glycogen storage, reduced ground contact time, improved muscle coordination, muscle unit recruitment increases, patterns of neural input, motor unit synchronization, or increased strength resulting in reduction of relative workload.